Okay, serious question. If we understand decimal number system and the computers understand binary number system, then why do we torture ourselves with hexadecimal, octal, XS3, BCD, gray code, alphanumeric code, and even stuff like extended BCD interchange? Well, wouldn't life be easier if we just stuck to one for us and one for the computer? Well, I also had this exact same doubt when I first studied this concept in engineering, and the answer is actually more interesting than you think. Okay, so you and your friend, when you guys are together, you might prefer to speak to each other in Hindi, but say in a more formal setting, you guys might prefer to speak to each other in English. Same way, when you guys are casually texting each other, you can use emojis and short forms like lol. But when you're writing a formal email, you will not do so, right? So the point is, you're the same person, but you switch codes, or more specifically languages, depending on the situation. And number systems work the exact same way. Decimal number system is our everyday human language, and binary system is the raw language of the machine. But in between, we've got these other number systems that make life easier in specific contexts. Binary strings can get super long. Imagine writing this 110010. Ugh, it's painful to read, right? One tiny slip and the meaning changes completely. Now, take the same thing in hexadecimal. Just 4 characters instead of 16, C6FB. That's why programmers love hex. It's binary, just compressed and readable. Octal did a similar job back in the day, grouping binary into threes to match early hardware. So, hex and octal are like shorthand for binary. Same information, just way more manageable. Okay, so why systems like BCD, XS3 and gray code? Now, these sound exotic, but they were born out of real engineering needs. BCD, or what stands for binary coded decimal, each decimal digit is directly stored in binary. So calculators and digital clocks loved it because it avoided conversion mistakes. The XS3 code added 3 to every decimal digit before converting. Why? It amplified arithmetic circuits back when hardware wasn't powerful. And now gray code. Now this one's clever. Only one bit changes at a time. That prevents errors in rotary encoders or sensors where tiny glitches in switching could mess up readings. Now, not everything in computing is just numbers. We also need to represent letters, symbols, and control characters. That's where alphanumeric codes came in. You've probably heard of ASCII. It maps numbers to letters and symbols. And now EBCDIC, Extended Binary Coded Decimal Interchange Code. This was used by IBM. It's another way of encoding letters, numbers and symbols, especially in mainframe computers. Without these, computers wouldn't even know how to represent the simple letter A or a spacebar. So the point is that you will probably not be using every single one of these codes daily. It's just that each one of these systems was designed to solve a very particular problem. Decimal is for humans, binary is for machines, hex is for readability, octal made life easier for early hardware, BCD and XS3 helped with arithmetic and displays, gray code solved error issues, alphanumeric codes and EBCDIC let us handle text and symbols. Together, they show you how information can be represented in many ways depending on what problem you're trying to solve. So, hope that cleared up your doubt and helped you understand a little about different type of number systems. Thank you for watching.